Lecture 4. Where is the color? One failure of science education. In this lecture, I will present an experiment that aimed at testing Model 3, coexistence, on children and adults understanding the difference between sensations and physical properties of objects. I will show that despite all the efforts of science education to separate the description of objects in terms of physical structure from subjective perception of the same objects, both children and adults still confuse their senses with physical reality. This is the main publication to this lecture. There are two ways to describe physical objects. One way is to describe the objects in terms of subjective qualities, as hard, soft, warm, cold, red, blue. Another way is to describe objects in terms of physical properties, as having molecular structure, temperature, or emitting light waves of certain frequencies. Science education aims to replace phenomenalistic perception of physical objects, for example, as being warm or soft, with the scientific description of these objects, as having temperatures or molecular structures. But how successful is science education at achieving this goal? The aim of experiment 1 was to examine whether 6- and 9-year-old children and adults can appreciate that the object's sensations are produced by their minds and are not physical properties of the objects out there. Sets of questions about 8 kinds of sensations were asked. For example, in regard to color, the children were shown a red pencil lying on the table and asked, "What color is the pencil?" This redness of the pencil, where do you think it is? In the pencil or in your mind? Aversion, in the pencil or in your eyes? The assumption was as follows. Saying that color is in the mind or in the eyes and not in the pencil would stand for the understanding by a philosophically unsophisticated mind that the sensation of color is a subjective property.
This graph shows that only a minority of 6- and 9-year-old children localized such sensations as color, redness, consistency, hardness, weight, lightness, and temperature, warmth, inside their minds and sense organs, with the majority saying that these sensations are in the objects themselves. A similar tendency to localize sensations in the physical objects, albeit to smaller extent, was observed in regard to the sensations of sound, loudness, and taste, sweetness. On most sensations, adults performed slightly better, but not significantly differently from children. The only exception was the sensation of pain caused by a needle puncturing the skin, which the majority of 9-year-old children and adults localized in their skin, rather than in the needle.
We can therefore conclude that most participants considered sensations to be immanent properties of external objects. Adults did not show a significant improvement in their understanding of the psychological nature of sensations compared to 6- and 9-year-old children. The only exception was pain. The aim of experiment 2 was to contrast the participants' phenomenalistic perceptions of the sensual qualities, that these qualities are in the objects, with their rational understanding of that the objects contain not sensations, but physical structures, such as light waves or combinations of molecules. Participants were given the scientific explanations of how sensations of color, sound, and smell appeared in the mind. They were explained the physical mechanisms beside the processes that cause the sensations. They were then again asked the test questions about the sensation's location either in the mind or in the objects per se.
For example, in regard to color, Participants were shown this picture and told that the red pencil reflects large and slow light waves, and the blue pencil reflects small and frequent light waves. When the light waves enter our eyes, we start seeing color. The participants were then asked to repeat the explanation.
The results showed that children did not benefit from the explanations and answered the test questions by confirming that redness of the pencil, loudness of the bell, and smell of the perfume were in the pencil, in the ringing bell, and in the perfume. Adults improved on the understanding of the subjective nature of smell, but still localized color and sound in the objects that produce them. We can therefore conclude that science education fundamentally fails to replace phenomenalistic perception of sensations as being stuck to the objects by the rational understanding that sensations are in fact the products of the mind.
And the reason of this failure is that having this illusion makes practical sense. For most practical situations, it is easier to view the world in a phenomenalistic way than to refer to scientific constructions that produce the sensations. Just imagine how awkward this would be, instead of saying, "This apple is sweet," to say, "This apple has a molecular structure which triggers our taste buds that are responsible for our sensation of sweetness."
Summarizing the results of lectures 3 and 4, we can say that Model 1, replacement, works well for those phenomenalistic perceptions that are unstable, such as Piaget's phenomena, and when people's verbal judgments are tested rather than their practical actions. In regard to the stable phenomena and in solving practical tasks, it often makes sense to give up our rational knowledge and use our phenomenalistic perceptions instead. Model 3. The implications of these results for cognitive development can be put as follows. Cognitive development is not replacing our phenomenalistic perceptions with the rational understanding that science gives. Instead, cognitive development is a growing differentiation between phenomenalistic perceptions and rational scientific explanations of how the nature works. The end result of cognitive development is a complex mixture within our mind that consists of phenomenalistic perceptions and rational theories. When solving practical tasks, our choice of which of the two contrasting ways of representing the world to use is determined by our psychological comfort and circumstantial properties of the task, rather than by our belief in science.